So what is sequence? What's a sequence? It can be said that a sequence is a set of quantities arranged in a definite order, like a set of quantities, say 1, 2, 3, 4, 5, 6, all natural numbers like that way, or even 4, 2, 0, -2, -4, -6, or 2, 4, 8, 16, etc. Now, these are all examples of sequence. They are really a set of quantities that arrange in a definite order. This is a natural number sequence. This is a sequence where we can see that it's decreasing by number 2 for every term, like that way. And the next one is example of that multiplying it by 2 by the next term. So these are all our example of sequences. Now, there are two major type of sequence. Two major type of sequence we have. Two major sequences. What are they? A is arithmetic sequence and B we can say that geometric sequence. So today we are going to study this arithmetic sequences. So what is arithmetic sequences? This arithmetic sequence is also called arithmetic progression. Or simply AP. The characteristics of AP is that there is a common difference. There is a common difference between between successive terms. The terms of sequence are generally labeled as the successive terms. What are the terms? These terms are generally labeled as the first term is U1, second term is U2, next term is U3, U4, like that. UN is the nth term. Now, when we say that U1 is first term and also this is popularly denotes as A. The common difference, that there is a common difference, the common difference, or later I'll tell you that CD is termed as D. And what is D? D is nothing but the difference between the successive terms, means U2 minus U1 equals to U3 minus U2 equals to U4 minus U3 equals to dot 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 UN minus UN minus 1. So this actually goes on like this way. So when we call that nth term, so how to find out the nth term then? The nth term of sequence, which sequence? The AP progression or AP sequence, can be found by UN equals to A plus N minus 1 D. Now, as I said already, for any arithmetic sequences, then what we have learned, just refreshed it, that any arithmetic sequence can be denoted as like this way. Each and every term can be denoted like this way. And U1 is called first term of AP. also called a un, can be found, sorry, before that here, simply tell that there is a common difference or the CD, and it can be termed as simple D, and we found it like by subtracting the successive terms like U2 minus U1, again U3 minus U2. So this is also the characteristics of our arithmetic progression, that all these terminologies having only one difference, that is D. It means U1 is A, but U2 is A plus D. Now, value of D may be negative, may be fraction, whatever it is. U3 equals to A plus that U2 plus D, so A plus 2D. That allows us to derive the nth term as A plus n minus 1 D. The practice exercises what we'll do now is only on this, finding out this nth term using this thing and all these characteristics of D means U2 minus U1, like that way. So take some examples. Now here is a problem as given. Show the following sequence are in AP. Which sequence? Now y plus 1, y plus 3, y plus 5, dot, dot, dot. Find the common difference. Find the nth term. So, when a sequence is in AP, what would be their characteristics? That if you're tagging it U1, U2, U3 like that way, then for AP, U2 minus U1 should be U3 minus U2. Just examine this thing, that it is, we are finding that y plus 3 minus y minus 1 is coming as 2, and here is also U3 is y plus 5 minus y minus 3, it is also coming 2. So this equation is established, and yes, this equal is established, and then it is in AP by saying that they have the same common difference. So here I was also find the common difference, the same thing, the D equals to U2 minus U1, and whatever, it's a 2. So the common difference is 2. Now there is another question, what is the nth term? So to finding out the nth term, there it is, it's a B. B. So C is, what is the nth term? So we know that Un equals to A plus n minus 1 D. Here D is 2, and we have A is y plus 1. A equals to y plus 1 given. So just simply replacing this fact, that y plus 1 instead of A plus n minus 1 to 2. So y we are getting by simplifying this thing, that y 2 multiplied by n is 2n, then minus 2 and plus 1 is minus 1. So this is my nth term of the given sequences. Okay, so let's move for another example. So the next example, what it's asked for, that if n plus 5, 2n plus 1 and 4n minus 3 are 3 consecutive terms of an AP, find the value of n. So what we know, that any term there, but they're consecutive terms. So the difference, to find out the difference, if you subtract 2n plus 1, if you subtract that n plus 5 from this 2n plus 1, and the 2n plus 1 we are subtracting from the next term 4n minus 3, the difference would be the same. So from that common difference formula, that then D equals to, D equals to 2n plus 1 minus n plus 5. Again, D equals to 4n minus 3 minus 2n plus 1. And as D is the same as there in AP sequences, then this is equating each other. So what we are finding from here, this equation 1, if we termed it, it is n. So plus 3 minus 5 is 4. So this is my number 1 equation. And what I am getting from here, it is 2n minus 3 minus 1. So minus 4. So this is my 2. So as far as they are in AP sequences, A1 equals to 2, this equation should equate. So n minus 4 equals to 2n minus 4. So just interchanging what we are having, 2n minus n equals to 4 minus 4. So n equals to 0. Now simply whether we are correct or not, we can replace the value of n in the sequence. So what we are having, that sequence is now 5, 1 and minus 3. So now you see we are having here, it's a sequence and it is decreasing. D value of D is 1 minus 5 is minus 4, and here also D equals to minus 3 minus 1 is minus 4. So yes, we are correct. So it's a counter check we can do always, like for this kind of sequences. Now take one more example. Here the first three terms of AP are 1, 6 and 11. Find ninth term and which term will be equal to 151. Now you see what information it gives us is the first three terms. So U1, or the most commonly we are telling it's A, is 1 given. Now what is the D? Let us find out the D from this sequence. The 6 minus 1 equals to 5 is my D. Okay, just using this information, I can write the ninth term as U9 equals to A plus n here is 9, so 9 minus 1 D. Simply writing the formula and substituting the values over here. 1 plus 8 minus 1, 8 into 5. Okay, so that gives me U9 is 41. So okay, my first A answer is there. The ninth term of this sequence, given sequence, is 41. Now let us find out the B. What is asked for, that which term will equal to 151. Now term we don't know. So say nth term. Now how do we write with this information? That Un would be A is here 1 plus n minus 1 and D is 5 already. So this would be the nth term. Now already Un has been stated is 151. So replacing that value, that 151 equals to 1 plus 5n minus 5. So simply interchanging and the sign as well. What we are having that 5n equals to 151 plus 4. We are doing the subtraction and coming over here, it's addition. So 155. So n is 31. So n 31 means my term is 31st term. So it is U31. We always that n is 31. It is not n, but we'll say U31 or the 31st term. 31st term. That would be my answer. Now take one more example, the final example of the day, that for a given arithmetic sequence, un equals to m and um equals to n. Then find common difference CD and the term un plus n. Now See, in the arithmetic sequence, it has been given like that way. What we can say that my U1 equals to A, and CD equals to D. I don't know. So I can write the UN term with the formula that UN equals to A plus N minus 1D, and that is given that my UN is M. So I'm just replacing the same thing and writing it down that way. And also, if using this formula, I can write my UM equals to same A plus M minus 1D. Now that is given as, what is it? UN is M and UN is N. Now simply simplifying these two equation. This is, I'm saying 1, this is 2. So what I am doing, I am subtracting from one another. Like that way. Okay, just do the, okay, first do the subtraction over here. So here I am getting, by subtracting, the A is nullifying in my this side, and N minus 1 means ND minus D, and here it is also minus MD plus D equals to M minus N. Okay, I'm nullifying DD, getting D common, M minus N over here, and by, okay, just do one more step here. Just do one more step. I'm just taking this D common, that N minus M equals to M minus N. So just subtracting, or not subtracting, just multiplying it with minus 1, the both side, what I am getting, D equals to minus M minus N, again M minus N. So it is minus 1. My D is minus 1. So common difference is minus 1. So how come that this B will come? UM plus N. This term I have to find it out. Yeah, to find it out, UM plus N, I'll write the same formula, that A plus M plus N minus 1 into D. Now here D is minus 1. Here I already know my D is minus 1. So what I am doing, I am just interchanging minus 1, multiplying. So 1 is plus, now minus N. This is my U M plus N. But how come I find out my A? From the value of the D here, I know that my U N, any value I can take, like that way. Like here in number 1, if I am writing the value of minus 1, I can find out A in terms of M and N. So I am doing that UM, that equals to actually N, equals to A plus N M minus 1, D is also minus 1. So what I am having, N equals to A plus 1 minus N. So what I am getting, value of A in terms of M and N, it is M plus N minus 1. So same thing, I am replacing it over here. So UN plus N equals to, I am replacing A over here. What I am getting, that M plus N minus 1 plus, now without bracket I am writing it down, that 1 minus M minus N. And all are nullifying each other. So this term comes to 0. So the term UM plus N is 0. That is my answer. Thank you very much. Hope you will enjoy this lesson and will continue to study over here and also practice something on your own, and let me know if you need something and I can be a help to you. Thank you.